Welcome to Clear Coding. I'm your host, Stephen Clary. Today's video is one of a series of videos that I uploaded to Vimeo almost 10 years ago, which is why I'm going to look completely different for the rest of this video. But this video is kind of exploring how asynchronous code used to look like before async and await what came on the scene. So, hope you enjoyed this blast from the past, and I'll see you on the other side.
Hi, this is Steve Clary, and today we're taking a look at implementing asynchrony using events. And we're solving the simple problem, the basic problem, using events to make it asynchronous. Now, events are coming from an object-oriented programming mindset, so a lot of the really old asynchronous code follows this kind of a pattern. So first, before we jump into the asynchronous part, let's look at what the synchronous code looks like. So again, our simple problem that we want to solve is we're going to download a string from the internet and we're going to save it to a database. So if we have these, in the synchronous world, we have, say, a method that will allow us to download a string from the internet. And I'm just going to call this download string. And we're going to also have another method that allows us to save it to the database. To say as such. And we want to compose these methods. What does this look like when our application is going to download and then save? Well, this is pretty straightforward in the synchronous world. We'll write our own download and save method here. And we're going to take that data from the internet, download it from the internet, and then we're going to save it to the database. Pretty straightforward. You're talking 7 lines, including declarations. Not a huge deal, right? This is incredibly easy to maintain. It's obvious what the code does just by looking at it. This is the synchronous world. So let's take a look at what this looks like when we start moving into asynchrony, and specifically using events for asynchrony. So before we implement this, let's take a look first at how our declarations change. So now we're going to have a download method that actually just starts the operation, that starts the asynchronous operation, and we're going to have an event that's raised when that download is completed. So download complete, download completed, we'll call it. So this is an event that's going to be raised when this download completes, and it's going to pass us some data that's string with the data that was downloaded from the internet. And similarly, we're going to change our save method to work with the database. We're going to make that asynchronous. So in this case, there's nothing actually being returned, so we're going to have like an event of void that's not passing us any information. Save completed. So this is what the API that we're going to consume looks like. And similarly, when we publish our own API, we want it to follow the same asynchronous pattern since we're in that world. And so we're going to raise our download and save completed event when we're done. So let's go ahead and implement this and see what it looks like. Well, just like before, the first thing that we're going to do is download, only in this case we don't get a string directly, we start the download. And actually that's not the first thing that we do, because this is event-based asynchrony, and this is a little bit, it's a little counterintuitive, but on most event-based asynchronous systems, you actually have to subscribe to the event first. And this handles situations where, like with a download, for example, if it was already in a cache, and so the download could actually complete synchronously, or perhaps immediately after returning here, and it's raising that event, and we haven't already subscribed to it, so we miss our event notification. So most of the time, this is not true for every single platform, but for almost all platforms that use event-based asynchrony, this is true, where we actually have to subscribe to the event first, and then we start the operation. So the first line of code that I wrote is down here, and that's going to stay down here. And then before I do that, I'm going to subscribe to the event. And we have this download completed event coming in. And the thing is, with event-based asynchrony, when these events are raised, they're raised no matter how the event completes. For example, if there's an error downloading the string. In the synchronous world, the errors are just raised as exceptions, and they're propagated naturally through the synchronous method. You don't have to do anything special. In the asynchronous world, you can also get asynchronous exceptions. Perhaps the URL is misformed, so download could throw. Or perhaps, I'm going to assume that that's not possible in this situation for simplicity, because that complicates the code even more. But regardless, any kind of event-based asynchronous system also notifies you of exceptions or errors in its event handler. So I'm going to just kind of make up what this looks like here. We're going to call this download result. And I'm going to say that this can have an error. So I'm going to say if download result has an error, then what we need to do is trigger our own. We need to propagate this error out through our own event down here, so that our callers are also notified of the asynchronous error. So I'm going to trigger our own download and save completed event and I'm just going to pass along, the same error. Okay. And then I'm going to return because this is done. We're done processing that. That completes our download and save logic. If this doesn't have an error, then the next thing that we want to do is, once we have our download result, the actual result, like the data, then we want to save that to the database. So I'm going to call save, and we're going to pass in this download result.data. Let's call it. Okay. So in this case, we've got download completed. All right, coming in, we check for errors, and then we save it to the database. And once again, since we're event-based asynchrony, before we save it now, we also have to hook up our save completed event handler before we call save. So we're going to call this save result, and coming in here, and same thing as before, we're going to check this for errors. If the save result has an error, then we want to pass that along to our download and save completed event with save result.error, and then return. Otherwise, we're going to proceed with our logic, and in this case, if the save if it completes successfully, then we're done. So we can just trigger our download and save completed, and there's nothing to send to that. It's an event that takes void, so that's that. Okay, so this is the complete logic, the asynchronous equivalent to the synchronous code that we were just looking at. Now you notice several things about this code. First off, it's 23 lines long, including declarations, instead of whatever the other one was, 7, right? So it's quite a bit longer. It's also a lot more convoluted. And this is exactly what code looked like in a lot of these event-based asynchronous systems. So we're talking early .NET, a lot of C++ code. Actually, the first real asynchronous program that I ever wrote around the year 2000 followed this pattern. There wasn't anything else available. And I've even seen JavaScript, like modern JavaScript, just as recently as last year, that is following an event-based pattern. In that case, they were actually using a message bus for events, and you would subscribe to the message bus, and then you'd have like one component sending a message to another component, and then asynchronously having to handle the result of that in its message bus event handler. It was very complicated. So this is a pattern that for the most part is older, but also can show up in newer code as well. And there's several problems with this pattern. First off, you have to read the code backwards. I mean, we wrote the code backwards, right? I mean, the first line of code that I wrote in download and save was in fact this download call. That was the first line of code that we actually wrote. That's logically the first thing that you do. So you end up having to read the code backwards. Well, first we download and then we save. That's logically what's happening here, but it's not obvious from the code. And you might be thinking to yourself, okay, well, this isn't too bad. I understand what this code's doing, right? Well, we just wrote it. I mean, literally just wrote it. Try to, I challenge you, if that's what you're thinking, I challenge you to pause this video and come back to it tomorrow, after 24 hours. Take a look at this code and think, is this really as maintainable as I thought it was? Or, for example, next year, because we're talking code maintenance issues here. So the first thing that's problematic with this approach is that you have to read the code backwards. The second major issue that I have with this code is manual error handling. And in my experience with almost all asynchronous patterns, until you get to async and await, it is the error handling, the manual error handling, that is one of the primary sources of latent bugs. So you just forget to check error. It's an easy thing to just leave this off. And then what happens? Your download result.data might throw, and suddenly you're throwing directly from an event handler. That's not an exception that gets captured and raised on download and save completed. So you're stepping outside of your pattern then. And these kinds of manual error handling that is required by this pattern is a source of many bugs. Again, when you're developing on your own box, well, of course, you never run into these kind of issues. It's in production when this kind of stuff bites you. So this is a major issue, in my opinion, is the manual error handling. And the third issue with this code is that it's got some deep nesting. Now, we can clean this up a little bit, and in fact, in many environments, you actually have to clean this up a bit. So if we were to, say, introduce some private helper methods, saying like our download result, or download completed handler method that took a download result, all right, and we stuck our code in here. There. So we're going to break this out into a separate method and download it, save completed. There you go. And we're going to do the same thing for our next method, which is our, oops, I'm sorry, that should be our download completed handler, just to make this code right for anyone who's following along. Of course, we are using a fake language, so it's not like this is going to compile anyway, but we have our save result coming into our save completed handler, and we're going to split this out into our own nested or unnested method as well. So now we've unnested these. Right? And then also in here you can do things like, unsubscribe when you're done, for example. Like, say your download completed is now unsubscribing your own self, that kind of thing. Normally you would do that with this event-based pattern. There are some scenarios where that's actually not necessary. I'm going to leave it off for simplicity. But so using this kind of pattern, we're now up to 27 lines, and we've split this out into separate methods where it's not as nested, right? However, this is just able to clean it up just a little bit. Now our logic to just download and save is spread across 3 different methods instead of 1. That's a trade-off that you have. You either spread out your logic across multiple methods, or you deal with deep nesting in a single method. So either way, it's not the most maintainable code. And this is actually where, if you're dealing with code with this kind of a pattern, one thing that really helps is to actually write out a state machine, because that's what you're actually dealing with here, is a state machine. It's actually helpful to write out the state machine and show all the different transitions and what goes where and that kind of thing. Especially if you're dealing with like real world code, anything more complicated than download and save, you're gonna have to write it all out in order to really visualize it. And flowcharts and state machines work great with this kind of old school object-oriented programming style code. And the final problem that I have here with this code is that any kind of non-trivial logic, so we're talking any kind of loops where you're for eaching over something, or any kind of a join, like if you're doing 2 different asynchronous things and you want to combine the results of those when they both complete, that kind of thing. Any kind of logic like that requires manual state machines. And we're not going to look at that today for sake of time, but next time we're going to look at a slightly more complicated example, starting from this code that we have up here on the screen now. And we're going to add in, we're going to take the next step towards complexity. It's not even a problem that I would call complex. It's still a simple problem, but this kind of problem is trivially simple. Download and save, that's trivial. The problem that we're going to look at next time is a little bit more complicated, but it's still actually pretty simple. It's just not trivial. So join us next time. We're going to look at adding state to this and see what that actually looks like with event-based asynchronous programming. Thank you.